Saxon Advanced Mathematics Lesson 20. Welcome students to a really nice, short and sweet review lesson. We're going to talk about the two special trig triangles today, and you know them by their specific names. The first one is the 45-45-90 triangle. Let me remind you what it looks like and how we remember it, then I'll tell you what it's good for. A 45-45-90 degree triangle means that it's a triangle, a right triangle, in which the two other angles are both 45 degrees. All right? What's cool about this is we can easily memorize the lengths of each side. Now, in the particular 45-45-90 triangle that we may be talking about, it might not have legs of 1 unit long, but they will always be proportional that way. The two legs will always be the same length, and if you take the measure of either one of those legs and multiply it by the square root of 2, then you'll get the length of this. So it's cool because those ratios always stay the same as they always do for trig triangles. But instead of relying on our calculator to use these values, we can make the calculations ourselves. We don't need to rely on the calculator. The good news of that is that it's easier and straightforward. The bad news is that if you prefer decimals to square roots, you won't be happy because we end up with square roots. But square roots are fine, you guys. Don't be afraid of them. They're cute. Okay, how do we know that square root of 2? Well, here's how we can prove it. Right? Pythagorean theorem says that if each of those are 1, then that's 1 plus 1, and this is 2. And then we take the square root. We discard the negative value because I'm pretty sure that's not a negative length. And we get c equals the square root of 2. So memorize the 1 and the 1. That's easy. But if you ever forget what number goes there, just know that you can quickly use the Pythagorean theorem to calculate that. And you don't have to just rely on your memory. Okay, so this is a super cool way to help your brain remember this. But seriously, just memorize this. And then there will be lots of problems in our future where you can rely on this picture and you don't need a calculator to do the work. All right, we're taking these the examples, we're going to take slightly out of order because John introduces both triangles and then starts with the problems, and he mixes the two different kinds together. I'm not doing it that way. I'm giving you first the two problems that relate to this triangle. So in the first one that we're going to do, 20.2, the problem is we're supposed to evaluate 7 times the sine of 45 degrees. Okay, so this is exactly what I was talking about. This triangle isn't so tiny as this one. This triangle has a hypotenuse is 7. So we're multiplying this by 7, but it's all going to work out fine. Sorry, I just don't want to talk right now. My words keep coming out sideways. So I'm going to pretend that that's not there, and I'm going to redraw the triangle. And just for fun, I'm drawing it in the other direction. Why did I draw it that way? That's the way the book shows it. I prefer to see it this way. 1, square root of 2, 45 degrees in each corner. That's we call it a reference triangle. Now I need to remember which pair of sides forms sine. And just to be thorough, sine, cosine, tangent, I'm going to write down the pairs. Remember, trig functions are nothing more than fractions made out of the different sides, right? Oscar had a hold over Arthur. There's so much less intimidating when you realize they're just fractions. You're just comparing different sides of the triangle and giving the names of those ratios weird names, right? Sine, cosine, and tangent. Okay, we want the sine of 45 degrees. So we want the opposite over the hypotenuse. And we're standing here, right? So the opposite side is 1, and the hypotenuse is square root of 2. Oh, okay. And now, so that's how much this is, right? So now we just take 7, and I'm going to put it over 1 because we're in the fraction club, and we're going to multiply that by the sine of 45 degrees, which is 1 over square root of 2. You're right, we do have to rationalize that, but we'll do that at the end. So here we get 7 over square root of 2, and now we'll rationalize. And our final answer is 7 times the square root of 2 over 2. All right, that is the ratio of the sides for a triangle that is 45 degrees multiplied by a factor of 7. All right. Interesting. We're used to seeing these values as decimal numbers. We could convert that into a decimal, right? With a calculator, we could find the square root of 2, we could multiply it by 7, and then we could divide it by 2. That wouldn't be hard. This is the new kind of answer we're going to accept for trig functions, though. We're going to accept them as fractions with radicals. And whenever we see that, our brains will automatically know, oh, that comes from one of the special triangles. That's why it looks different than just 0.864 or whatever the heck. Okay, let's do one more of these, and then we'll look at the other special triangle. And I get to redraw my triangle now because I turned the page. Remember, when you do your homework, you don't have to rewrite it for every problem, but make sure that the formulas, diagrams, etc. that you need are on that page somewhere. I think you probably fit a lot more on one page than I do, but that's okay. Example 20.4, we're skipping to that one because, again, it relates to this triangle. And we're supposed to find 10 over the square root of 5 times the tangent of 45 degrees. Okay, so the first thing we do is we remind ourselves, okay, what the heck is tangent? And I just like to write them down in a row because it helps me. Oscar had a hold over Arthur. Tangent is over Arthur. So the tangent of 45 degrees equals the opposite side. Oh, I didn't put my values on. Here we go. The opposite side is 1 over the adjacent side. Oh, also 1. Interesting. Okay, so that means the tangent of 45 degrees equals just plain 1. So then when I put this in for that, I just substitute the value in, right? It's 10 over the square root of 5 times 1, or 1 over 1. That makes this just 10 over square root of 5. I know I'm showing way more work than you would need to. I'm just making it super cute. So this is 10 times the square root of 5, if this is your idea of cute. It is mine. Then we can cancel, right? The 10 against the 5. We rationalized it. Now we can cancel. So our final answer is 2 square root of 5. And that's the correct answer. Okay, so we calculate the value of the trig function, we multiply that by this coefficient, and then simplify. Okay, again, don't let the radicals freak you out. Remember that we could turn this into a decimal number if we wanted to with a calculator, but that's the whole point of these special trig triangles, is we want to be able to do some trig equations without having to fuss around with calculator, and I love that. So I'm on board with this lesson. I think it's a good one. All right. The other trig triangle, as you may recall, is called the 30, 60, 90 triangle. It's a little bit more complicated, but not a lot. Remember that to imagine this triangle, it helps to start with an equilateral triangle that's oriented like a backwards play button on any device that you can imagine. We're gonna start with this. We know it's an equilateral triangle because we said so. So that means it's 60 degrees, 60 degrees, 60 degrees. And instead of making the outside legs 1, like we did in the 45, 45, 90, we're gonna start with each one of these outside legs being equal to 2. That's another reason I like to do the 45-degree triangle first, because then, here's another picture of it. We start with naming the sides 1 and then calculate that. With this one, we're gonna start by naming the sides 2. So that kind of makes a certain amount of sense to me. Now what we're gonna do is we're gonna take a very sharp surgical knife and we're gonna slice this in half horizontally. We're gonna disregard this bottom part, but we're gonna take the new part and we're gonna redraw it over here. Well, I am, yeah, you are too, just so we can see it more clearly. This now becomes a 90-degree angle because we cut it right there perfectly straight. This angle has been chopped in half, so that now is a 30-degree angle. This angle is untouched, so that's 60 degrees. 30 plus 60 is 90, plus another 90 equals 180. Okay, we did that well. The hypotenuse is still 2. We haven't touched that. This side, the short leg of the new triangle, is half of what this distance was before. So we take that 2 and we cut it in half. This is 1. And along here, this is a whole new dimension. So we're gonna need Pythagorean to come and help us figure that out. So I'm going to use Pythagorean theorem to solve this. I'm going to take careful note to remind myself that this is one of the legs and that's one of the legs. So I'm going to call the mystery leg a squared plus 1 squared equals 2 squared. Make sense? A squared plus 1 equals 4. I subtract the 1. A squared equals 3. Take the square root. Disregard the negative value for that because that's not a negative length. And we get A equals the square root of 3. So there's the final part of this triangle. Again, just like with the other one, if you can get these two, which are pretty darn easy when you start with this triangle, you can use Pythagorean to solve for that third piece, the other leg, just by using Pythagorean theorem. So if your memory fails you, you can calculate that difference. Okay, memorize this one as well. They're super useful. We're going to use them a ton, right? All right, let's do, oh, the other thing about this triangle, because there are different angles, right? In the 45, 45, 90, they're the same. Sometimes we'll orient ourselves to the 30-degree angle, and other times we'll orient ourselves to the 60-degree. So we're gonna learn to kind of flip back and forth from either vantage point, but we just have to be really careful that we get all of the legs in the right place relative to which angle we're standing at. You'll see what I mean. Okay, so example 20.1. Now we're going back and filling in the ones we skipped before. We're supposed to find the tangent of 30 degrees. Okay, let me write this one more time. Sine, cosine, tangent. Oscar had a hold over Arthur. I'm sure, I think we've reviewed already this year that this is Oscar the Grouch and Arthur the Aardvark. And Arthur accidentally on his way home from school, he took a shortcut through an alley that is Oscar's alley. And Oscar doesn't like characters from other stories coming down his alley. So Oscar jumped him. And he is, excuse me, I'm yawning, but I'm not in the least bored. He is beating the ever-loving daylights out of poor Arthur. He's jumped out of his trash can, because you know he's not just a puppet in real life. He can jump out of his trash can. And he's got Arthur down on the ground, and he's choking him. He's holding him down, and he's just beating him mercilessly. So that's my sentence here. Oscar had a hold over Arthur. You can memorize this as Sohcahtoa, Sohcahtoa. That's fine, but the Oscar had a hold over Arthur is far more interesting and poetic to me than made up words. Okay, we need tangent of 30 degrees. So here's my triangle right here. I don't have to redraw it. I'm this dude, so I need the opposite side, which is 1, over the adjacent side, which is square root of 3. It's that easy. Now all I have to do is rationalize the denominator. And for my final answer, I get square root of 3 over 3. That's the right answer. Some students get really weirded out that this isn't simplified, but this is. This looks like it should be factored or something, right? But no, this is preferable to this because we don't like to have irrational numbers in our denominators, right? As mathematicians, we've all agreed it's much better to have a square root or a rational denominator than an irrational. So that's the whole idea there, is we want to fix the denominator and make it a rational number. Okay, one more problem, and then we're done with this lesson. I hope you're not too sad, because this one went by really fast. Example 20.3, and this one we're supposed to take 4 times the square root of 3 rather, and multiply it by the cosine of 60 degrees. Okay, that means I need to redraw my triangle, and this time I want to be at the 60 degree angle. So I'm going to draw it like this. I know that's 60, and I know that's 30. Okay, now I have to just make sure that I get my sides in the right place. I know that the hypotenuse is 2, because that's the part that I didn't chop. And I know that the short end is 1. And that's the side between 60 and the square root. That means the other leg must be the square root of 3, because I remembered it's 1, 2, 3, but the 3 has the square root. All right, in the 45, 45, 90 triangle, the square root is on a 2. So that helps me remember, okay, it's not on the 2 in this one, it's on the 3. All right, we're standing here in our vantage point. Cosine, oh, I'm going to write them again. Sine, cosine, tangent. Oscar had a hold over Arthur. I don't expect you necessarily to have to write these down every single time. I know that at this point you've got them pretty well memorized, but that's just part of my teaching jam, is making sure that you understand where I'm getting this. Do make sure you've got this memorized really, really well, though. If you do, you don't need to write it down, but if you're still a little shaky, just write it down a few more times. All right, so we're going to find the cosine of 60 degrees. That's going to be the adjacent over the hypotenuse. The adjacent is 1. The hypotenuse is 2. Okay, that seems fairly straightforward, right? Then we're going to multiply this fraction by that. So it's 4 square root of 3, and I'll put that over 1, times 1/2. All right, I can cancel there and just bring that down to a 2. And so my final answer is 2 times the square root of 3. There's no units to put on it. It's not a, this isn't a angle measurement. This is the ratio of the two sides multiplied by that, right? Cosine is a ratio. We made a fraction, then we multiplied it by this coefficient for reasons that aren't obvious to us in our world. Later we'll understand why. That's the right answer. Yay! We're done. We are going to use the heck out of these trig function or special trig triangles this year. We're going to use them a lot. So commit them to memory, draw them on the shower door or the mirror after your shower and it's all steamy. Write them in the chocolate pudding that your mom gave you for breakfast. Wait, what? I don't know. Just do it over and over. Write them, remember them, think about them when you don't have other things to do. I know you won't really do that. But seriously, the more you can burn these into your brain, the better off you will be. Okay, I'm done. Goodbye.